Hi, chemistry students. This is after school on a Thursday at the end of a week. I know this might be recording for future students who are also absent on this kind of lesson, but we were doing a lab today. So I wanted to show you some lessons about it. I'm going to go ahead and take my mask off since I'm not in front of kids, but also I used the goggles here to do an experiment, which is what I'm going to be doing here shortly to explain what you missed today. It's just like the third or fourth day in the heat unit, but we are looking at a lab. And the main focus of today was to do a lab. And here is the paper. It is this, move this a little closer to the screen here. This is this lab investigation on heat exchange. And so we used hot water and cold water, and we basically mixed them together to get the temperatures known of each of the hot and cold, and we're going to mix them together to see what the final temperature is. That's the ultimate goal of this lab. So I wanted to visualize it for you. So anybody that missed on this day or missed, on this day and future years, you'll be able to see this video. Okay. So before we do that, we are also in this particular school year trying to also collect. I gave this assignment out on plastic waste cleanup as an assignment after the matter test. And this whole week, starting into heat, I was wanting you guys to turn this in and look up these YouTube videos. It's actually linked in Schoology in the top of your page, but I wanted you guys to get this turned in. So please work on these questions from the internet, find the answers, and then answer what do you think about this problem? And then also share this with other people and have them answer question 4 and have them sign it and have you turn it in. It's going to be a test grade, a simple 10-point test grade, but it's going to help quarter 1's grade. So I just wanted to give you a heads up that I did stress to get this turned in by Monday. Okay. Please send me a text if you need any help getting the questions answered on 1, 2, and 3, just because of what you missed. Don't even hesitate to contact me this weekend about it. Okay. We did cover these notes on Monday about heat and energy. Understanding that heat is the energy flowing from warmer to colder. So we're going to be actually doing that today and measuring the temperature of hot water and measuring the temperature of cold water and observing how the heat flows. Okay. So I just wanted to iterate, this is what we covered Monday. And then we went over these answers to the vocabulary, and we went over these conversions of units too. So I'm going to make a separate video going over the actual next day notes, which was for Tuesday, to go over these problems, but I will do that on another video separate from this lab. Okay, just wanted to give you a heads up what we've been doing all week, this week after the matter unit test. Okay, so let's go ahead and focus on the lab. Okay, we have this lab paper. I have attached it to your email or correspondence with this video. Also posted in Schoology as well. Okay, but we're going to use 2 styrofoam cups. So I have 2 cups here. Okay, we have 2 cups. We're going to make 1 hot and 1 cold. Okay, and we're going to be measuring out volumes of water. So I'm going to be doing that here, trying to set up where we're going to have a little bit more space so you can see what I'm doing. We're also going to write down the numbers. Okay, so we have a cup for hot and a cup for cold. I'm going to go ahead and just arbitrarily pick 40 mils. 40 mils. So we want to measure exactly as close as we can to 40 mils. And I'm going to do 40 mils of cold and put it in this cup. And I'm going to do 40 mils of hot and put it in this cup. And I really want to do the cold first because it's easy to get the temperature. It stays pretty consistent. But when you have hotter temperature, even though we're using these insulated cups, the styrofoam cups is very good insulator. That happens to be one of your questions on the back of the page about why we're using the styrofoam cups. But we're going to do 40 of the cold. I'm going to go get that out of the sink, and then we're going to get 40. I've got hot water warming up over here on the side of the room, which I'm going to bring over here. You'll be able to see it kind of steamy a little bit, but I'm going to use cold water and hot water and then use a thermometer to measure its temperature. Okay, so we're going to use a thermometer and record that. Okay, we're actually going to use Celsius. So right now my room temperature is about 22, which is a lot different than at home. At home, your temperature is probably in the 70s or 68 in your home, but that's in Fahrenheit. So a lesson next week, we are going to see how to go between Celsius and Fahrenheit and be really comfortable with these temperatures, with what this kind of range of temperature is. So when we have colder water, we're going to use in the 20s. And my hand is warming it up at the moment because I'm holding on to the detector. And then we're going to use hot water, which could be as high as 60, 70, 80, all the way to boiling water, which is 100. So just wanted to give you a heads up. We're going to use Celsius for this lab. Okay. So I'm going to go get 40 mils of water real quick. Okay. Give me a second here. 40 mils of water. And I'm getting it out of the tap next to here, next to the video. I should have had that ready. I do have the warm water ready. I just forgot to get the cold water ready. So we've got 40 mils of cold water. I just measured it out. And then we have, we're going to have 40 mils of this warmer water, which I just took off the hot plate. Okay, so this is my warm water here. This is my warmer water. You can actually see it kind of condensing a little bit from being warm, and you actually can see the temperature being really warm here. It's actually pretty high in the 50s and 60s, so it is pretty warm compared to this coming right out of the tap. Okay, so as you can see, it is reading around 40, so I'm going to pour it into this cup. 40 mils. Okay, and we're going to write this down on your paper. Okay, so we have 40 mils. We could just use a whole number since we're not being totally exact on the volumes, but we're just going to say roughly 40. And we're going to use 40 for the cold. So I went ahead and put 40 in both. Okay, our cold temperature, now that it's in the styrofoam cup, we're going to go ahead and measure that. And that reads, just let it kind of equilibrate with my hand on it. I want to just hold the top here. Let's let it get used to reading it. And it looks like it's 22, maybe 21.9. So I'm going to write this down, 21.9. Okay, and we've got all the columns labeled already, so we don't have to worry about writing it. We just need to make sure it's in Celsius, which it is. Okay, so it's 21.8. Let's go ahead and change it down to 8. Okay, and we'll double check it real quick before we mix the two. But right now it's 21.8, and it's more than likely going to stay that way just because the cold doesn't change, because it's just basically staying around room temperature. Okay, so now I'm going to pour 40 mils of the hot in here. 40 mils, and it is kind of warm, so I'm kind of being a little careful. You can see the steam coming here. I don't know if you could see a little bit. You can see my hand. You can see the steam. You definitely know it's warm. But we wanted to do, and the kids, your classmates did this today in class, and they were trying to get equal amounts of hot water and cold water so we can make that an equal component. We're trying to see the measured, the actual transfer of the heat, and we don't want to have different volumes. That would make the transfer not a great, you want to make them volumes the same, because you're trying to show the heat transfer with the same amount of water. We're going to try to make these two waters equal, the cold water amount to the hot water. So the mass is a factor when it comes to transferring heat. We talked about heat being extrinsic depending on the amount. So it depends on the amount. And so I just did 40 of the hot and 40 of the cold. And I'm going to go ahead and make this a little bit better on the recording. You might still see me on the side, possibly. But anyway, so we have the cold and we have the warm. Let's go ahead and measure the warm. And it is still pretty warm. It's at 47 right now. It is going to go down the more I wait. So I want to just double check this temperature real quick and see if we can get it down to 21.8 again. because what we're going to do is we're going to mix the temperatures. We're going to mix the waters and actually see the transfer of the heat by the change in temperature. So let's put this in here, see if it goes down to 21.8. It's getting really close. It's within, you know, a couple tenths. Yeah, it's pretty close to 21.8, 21.9. So I think we're okay. Yeah, 21.8, we're good. So let's go take it back to the hot. Let's go ahead and get the hot temperature. We want to get the final hot temperature because the temperature of the hot will change because you're cooling it down, okay? So we have, it's getting even lower as we speak. So we want to try to get 46. Actually, it's a little higher now. I'm going to make sure it's right. I'm not going to touch the container because it does affect the temperature just by touching the container. So we're going to put 49.4. And then we're going to go ahead, if you guys can see that, 49.4.3 now. But I'll go ahead and change it to the 3 because it is cooling a little bit as we're waiting and talking. 49.2. So it is changing. We use 49.2. It's actually keeping going down even more. 48. It's cooling down. So I need to 48.2, 48.3, 48.3. We'll use that one. I'll change it in a minute. Let's go ahead and mix it. We're going to mix these two together, and we're going to see what this final temperature is after we mix it. So I'm stirring it around, getting it all mixed up, and we're going to use 48.3 now. It cooled down a little bit as we are working, okay? So now we're mixing it, and we're getting about, if you can see it on the recording, 35.1. It looks like it's coming to this point, 35.1. Eventually, it will keep cooling down, but right now the mixed temperature looks about even 35 degrees. So we'll go ahead and make that our mixed temperature, okay? So that's, in a sense, what we were doing, taking cold and putting it in with hot and seeing what the final mixed temperature is. And then we're going to be evaluating that a little bit more in detail on Monday. But I'll go ahead and give you some more numbers. I had the kids, the students actually did it 2 times, and then they were sharing their numbers with the whole class. So I'm just going to go ahead and write them down here. There's some other students that did theirs. Let me do this one. Another one that did 80 mils, and they transferred it from 61.0 to 21.5. That's their starting temperatures. And then they had a final temperature of 40.1. Okay. We had another sample with 40 and 40 mils, and they had it at 72 degrees. And the beginning cold temperature was 22, and they got it at 48.3. Okay, let me give you a couple more here. We had 50 mils, and they had it at 44.1 and 21.9. That's the hot, and that's the colder, the hotter and the colder. And then they got to 32.4. And then we had another sample with 70 mils, and they had 70 degrees, and they got it at 26.5. And in the middle, they had 46.8. So go ahead and write those numbers down. And what this is saying is actually looking at how much did the hot temperature go down and how much did the cold temperature warm up. So we're actually going to look at the differences between the cold in the final and the hot in the final to see how consistently they are transferring the heat, okay? And it always, and you can tell that it's going in the middle. So the hot particles of the hot water, that energy is transferred to the cold particles of the colder water, and they come in between with both having this intermediate amount of temperature, which means this has getting more kinetic energy. This is going down and losing kinetic energy, and they're mixing together, okay? So what we're going to do on Monday is actually look at this data in a different way. So we're going to transfer I'm going to try to do this here, and I don't want to be too, I know it's kind of sideways here, but what we're doing is we're looking at the hot water temperature is 48 and our final temperature is 35. So we're going to be subtracting these, and this might be a little bit of what we're going to do Monday in class, but I at least wanted to give you an idea what that's going to be about, and you'll be a little bit more prepared when you come in on Monday. So we're going to take 48.3 and subtract it from the final temperature 35, and that is 13.3 degrees different. The temperature went down 13 degrees. Okay, now with the cold starting at 21.8 and the mixed temperature is 35, we want to subtract, but we want to have a positive difference. So we're going to take 35 minus 21.8 and we're getting 13.2. Did you see? This is the data that we just did together, and this is going down 13.3 and this is going up 13.2. And you notice how the amounts going up and going down are the same. And they're literally going in the middle, and the energy is being transferred, okay? So we're talking about how the difference in temperature that of the hot water cooling should be very similar to the amount of change with the cold water getting warmed up. And you can see that with our data. Let's try another group's data. And you can actually write these down on your copy. I'm going to give you a paper. When you guys get this copy digitally, you're going to get 2 pages. This front page with the data, this page with the questions, which I'm going to be emphasizing question 1 to work on, and question 3, excuse me, not 3, question 2 and question 4. And then the other ones we're going to work out in class on Monday. Okay, so if we do probably make another video going over that, just so that, you know, in case other kids are absent Monday, then I can have another video. Okay, so let's go back and we're going to actually do this little, it's like a post lab. And this is basically notes today. This is what this is. We're going to do a little bit more of this on Monday, but I'm just trying to set you up with looking at the data here. So you're going to put the 61 degrees, and this was 21 degrees, and they met at 40. So the 40 is the mixed temperature. This is 40 here. And what you're going to do is see the difference. So we're going to take 61 here minus 40.1, and that's 20.9. That's going down 20.9. And then this one is 40.1 minus 21.5, and it's 18.6. So this time the students are really close, but not spot on, but they're close. 20 going down, almost 19 going up. It's a little bit off from each other, but it's close, okay? Let's do another one. We're going to take 72 degrees, and it's cooling down to 48. Okay, and then the 22 degrees of cold water is warming up to 48. Let's see what the difference is here. Okay, so we're going to take 72 minus 48.3. We're getting 23.8. And then we're going to take 48.3 minus 22.1, and we're getting 26. Okay, and so these, like these two are really darn close being equal. These two are kind of close. These are a little bit off, but they're getting in the same range. Let's go ahead and fill in the other numbers here, and you try to do the math and see what those come out to be. We're going to do this actually Monday in class, but I wanted to fill this out anyways because I got to have my numbers ready when we talk about them in class on Monday. Okay. And then we have a final temperature of 32. Oh, I messed up here. It's supposed to be 21.9 here. Sorry, I messed up. 21.9, and this is 26. I wrote these wrong. 32. That's 46, actually. This is 46. So go ahead and write these in. And you're going to subtract these two to get this. And then this 21, the final temperature is 32. You're going to subtract these two. subtract these two. So what you're doing is, this is the hot, this is the hot, sorry for moving it. This is the hot water cooling down, and it should very close to be the same as the cold water warming up. So do the math and try to see the numbers, and we're going to take some notes more on Monday, but I wanted to give you a heads up with actually seeing that. This is the data we just did in the video, and you actually see how close they are. They're almost identical, which means that the energy that's lost in the hot water, making it cooler, should be very close to the energy gained by the cold water, okay? Now, in the back of your paper, I had students say, hey, what happened to the temperatures of the hot and cold water once they meet together, okay? Aren't they just getting and molding? The hot particles are interacting with the cold particles, and they're coming together for a new intermediate temperature, okay? Aren't the temperatures just mixing, right? So you want to talk about that. Did that surprise you or not? That could be either way answer for you. Was it surprising that the temperatures went together? And then say why or why not. Basically, this is more of an opinion description compared to what should be written here. And then you're also talking about, why do we use the styrofoam cups? The styrofoam is very it insulates, and so the temperature doesn't change too much. Like, just to give you a heads up, we had a final temperature of 35, and this cup has been sitting here through my video, and it's just going down by 3 degrees. It's not cooling down a whole, it is cooling down a little bit, but not very much compared if it was in glass or another kind of cup. So all I did today was tell the students to do number 1, number 2, and number 4, and then we'll talk through 5 and 6 and 7 once we go over this comparison data of how much difference in the temperature going down from the hot, comparing it to the temperature going up for the cold. So after we talk about that, we'll definitely finalize these other questions, okay? Just wanted to give you a heads up, and there'll probably be a video part 2 about this heat transfer lab when I make it, okay? You guys have a good day. I'll say goodbye. We'll see you guys. See you later. Stop recording. Stop recording. Try one more time. There we go. I think I wasn't pressing the wrong button. Sorry about that, guys. We'll see you later.